Okay, so year 10, just to give you kind of a bit of an update, um, in our lesson on Wednesday this week, so from Wednesday onwards, we're going to be moving to covering some like brand new content. So far, all the work you've done with me has been revision of topics that you'll have done either in year 9 or in year 10. From Wednesday, we're going to start some brand new stuff, which is quite exciting. But for today, I thought I'd just do some recap of this, which you'd have learned in year 9, but you may well have forgotten because it's quite difficult. And so this is converting recurring decimals into fractions. That's what we're looking at today, converting recurring decimals into fractions. So here we have a recurring decimal. We have got 0.4 recurring. I know it's recurring because of this little dot above it. The little dot means it goes on indefinitely. Now, you cannot, this would not be a calculator type question. This would be a non-calculator question, and we need to use an algebraic method here. You will not get the marks for just getting the correct answer. I cannot stress that enough. Some of you, after a little bit of practice, will be able to find the answers in your head quite quickly. You will get no marks if you do that. You must use this method that I'm about to show you. So what we say is well, that x is equal to 0.4 recurring, and 0.4 recurring is written as 4, blah, 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 blah. So then, if that's what x equals, I can work out what 10x must be equal to. Because 10x, well, how have I got from x to 10x? I've times by 10. Now, 0.44444 times by 10 is 4.4444, etc. Now, with these two equations, you don't have to label them. I'm going to label them because it might help to make sense of what's going on. This is equation A and this is equation B. If I do equation B, subtract equation A, look at what happens. 10x subtract x is 9x. And then 4.444, take away 0.44444 is just 4. So now I've got 9x equals 4. So to find x, I'm going to divide both sides by 9. And when I divide both sides by 9, I get x equals 4. Sorry, I don't even know what that was. It was meant to be an equal sign. I get x equals 4 over 9. And so I've answered the question because I've converted this decimal, 0.4, into its fractional equivalent, which is 4/9. Okay? So now, year 10, I'd like you to pause the video and have a go at the question on the right-hand side by yourself. Okay, hopefully you've paused the video and had a go at that question by yourself. It's the exact same method. I'll just run through it again for anyone who it might be helpful to have a second example for, just to check you've done the right thing. So for this one, we begin by saying x equals 0.7. I'm going to start this writing again, it's horrible, sorry, year 10. We're going to start by saying x equals 0.77777 ... We then work out what 10x would be, and that would be 7.7777. Then if I label A and B, we can do B subtract A. 10x take away x is 9x. 7.777 take away 0.7 is just 7. And to find x, then we're going to divide by 9, leaving with x equals 7 over 9. If you've got that by yourself, that is fantastic, year 10. The second example then, perhaps a tiny bit harder, but we're going to begin it the exact same way. The reason I've said it might be harder is because here we've got 0.36 recurring. Important, because there is a dot above the 3 and a dot above the 6, that means the entire pattern is recurring. So in this case, I've got x equals 0.363636, etc. And then I'm going to do the same as before. You could work out 10x. So 10x is going to be, well, let's times this by 10. 3.63636, blah, 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 blah. Now, we can't just subtract them how they're currently written. And the reason for that is after the decimal point, the numbers are not exactly the same. Can you see after the decimal point, B begins with a 6, whereas A begins with a 3. They're not exactly the same as after the decimal point, and they need to be in order to do the subtraction step. So we're going to work out another multiple of 10x. This time, let's work out what 100x would be. 100x would be, we'll times by 10 again, so 36.3636. And this one we can call equation C. Now, C after the decimal point goes 363636, which means A and C are exactly the same. So we can do C take away A. So when we are doing equation C take away equation A, we are doing 100x take away 1x, which is 99x. We are doing 36.3636 take away 0.363, which is just 36. After that, I divide both sides by 99, giving me x equals 36 over 99. Oh, and actually, in this case, that fraction can be simplified because both the numerator and the denominator divide by 9. So 36 divided by 9 is 4. 99 divided by 9 is 11. So in its simplest form, our answer is 4 over 11. So year 10, what I'd like you to do then is pause the video and use the example on the left-hand side to try the question on the right-hand side independently. Once you've had a go, come back and see how you've gone with it. Okay, so just going to go through the run on the right-hand side nice and quickly then. So we begin x equals. We work out 10x. We work out 100x. After that, we look at our numbers after the decimal point. So this here is 7272, this here is 272, and this one here is 7272. So it's A and C, they're exactly the same. So again, we're doing C take away A. 100x take away x is 99x equals 72. So then to find our answer, we divide by 99. X equals 72 over 99. And actually, again, this fraction here can be simplified because 72 and 99, what do 72 and 99 have as a common factor? 9. They both divide by 9. So when I divide my numerator by 9, I get 8. And when I divide my denominator by 9, I get 11. So it's 8 over 11 in its simplest form. Okay. Right, a final one then, year 10 of this type of thing, and then you should be absolutely fine to crack on with some work that looks like this independently. So this one, we've got this up here. We've got 0.126 recurring to a fraction. What is really, really important is the dots are only above the 2 and the 6. So here we've got x equals 0.1, and then the 2, 6 pattern is what's repeating, 2, 6, 2, 6, 2, 6, like that. Okay, so it's 0.1, 2, 6, 2, 6, 2, 6. Then, same as before, we work out 10x, which gives 1.262626. And these aren't exactly the same after the decimal point, so we keep going. What would 100x be? That would be 12.62626. We've still got a problem because none of these are exactly the same after the decimal point. Like this one begins with a 1, this begins with a 2, and this begins with a 6. That's a problem. So let's keep going again. Let's work out 1000x. And that would be 126.2626. And so then after that, we can see that this one begins 2626, and this one here begins 2626. So this time round, if we just label them all A, B, C, and D, we are going to do D subtract B, because those are exactly the same after the decimal point. With that in mind then, we are going to do 1000x subtract 10x, which is 990x. And then we've got to be super, super careful here. We are doing 126.2626 take away 1.262626. Now the 0.26 bit kind of cancels out. So effectively what we're doing here is 126 take away 1, which is 125, like that. So x equals 125 over 990. Right, that definitely simplifies, and I know that simplifies because 125 and 990 are both divisible by 5. So when I divide them both by 5, I get 25, and then I can't even think, what's 990 divided by 5? 1, probably the 4. 150, that feels wrong. What have I done wrong? Oh, 9 there, carry the 4. Over 198, and I'm pretty sure that that here is its simplest form. Okay, so again, same as before, have a go at this question by yourself, and then pause the video if you need some help with it. Okay, so starting with this one then, here we would have x equals 0.6727272, blah, 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 blah. So then we get 10x. We get 100x. We get 1000x. And so then we're looking, we've got A, we've got B, we've got C, we've got D. We are looking for which options are exactly the same after the decimal point. So that's going to be D, because it's 7272, and B, 7272. So we're doing D subtract B, being super careful here. 1000x take away 10x is 990x. And then we're doing 672 take away 6. Now 672 take away 6 is actually at 666. Fun. Okay, so we've got 990x equals 666. So therefore we are going to have x equals 666 over 990. Now let's have a think. Well, those both divide by 3, don't they? Which therefore gives 222 over 330. Those both divide by 2, giving 111 over 165. And I'm pretty sure that there is in its simplest form. Okay. So year 10, that's how you convert recurring decimals into fractions. As I say, you must use that method. You cannot just work out the answer doing whatever you're doing in your head. You have to use that method in full in order to get the marks. So have a go at the questions from the sheet now. As ever, let me know if you get stuck or you need any help. Good luck.